Oh my God, there it is recording. Okay. Okay, I think that should work. Do I need to have a book up there? I think that should be okay. Okay. All right. So, the other day I went over kind of all of this again. So this was unit circle, unit being radius is 1. Ordered pairs are just kind of, if you thought of, if you put lines on there and made a grid like your Cartesian plane there, that's how you get to those points. These were all special triangles. On here it has degrees, it has radians, it has a coordinate pair and how to get there. Number on the outside was tan. And then those points were written cosine and then sine. So like I said, if you typed in sine 30, 0.5 will pop up. Okay, so this was your unit circle that we, in pre-calc, we spent many a days with. It became your best friend. Okay, so now what we're going to do, I'm just going to kind of take it back to graphing. We're going to graph sine, cosine, tan, and then their reciprocals. Okay, so on here, remember when we do the graphing, you're graphing an ordered pair, but we're not using degrees, because if I'm going to graph this on kind of an XY plane there, I don't know where 30 degrees is when I do that. But pi over 6, remember pi is 3.14, so I can get a number about how far I have to go over. So first one we're going to do is we're going to just kind of review sine, because sine and cosine I hit pretty heavily. Tan, I think I just showed you, and then we'll do the reciprocal ones. Okay, so sine would be, now the ordered pair is the radian and then sine. So we're going to come here at 0, 0. And then it's the second ordered pair was your pi over 6, 1/2. And then your pi over 4, square root 2 over 2. Your pi over 3, square root 3 over 2. And then when you got to pi over 2, you got to 1. And then what happened is those numbers started at 0, they increased, and then they just came back down, hit 0, and then you hit negatives till you hit -1, and then you went back to 0. So remember, with sine and cosine, these are periodic graphs. A periodic graph is a graph that repeats over a period of time. Okay, so remember with sine, and if you want to jot down kind of this graph here, I usually go out to, because if I just do sine of x and that's it, how do they have them? Oh, they have y equals, okay. Okay, so if I have something like this, I usually go out to 2 pi, because that's where you're going to see one complete graph before it repeats and does the same thing. Then I come here and I kind of put the halfway, and then these are just those quadrantal angles that I have there, so the ones that hit on the axis. If you both remember me, depending on which class you were in, it didn't matter. I really kind of had you graph 5 points. That's what I was really looking for, if you could label it and kind of graph it out. So I go up here to 1, I went down here to -1. Sine started at 0. At pi over 2, it hit 1. At pi, it was back to 0. At 3 pi over 2, it hit -1. And then at 2 pi, it hit 0. And then I would just keep repeating. I would hit those 5 points and keep going. Even before here, if I went down, remember, it's a graph that looks like this, but it kept going in this direction. It's not like it If you were at negative pi over 2, it'd be down. And so that you kind of have to watch that it's a graph that keeps going and going. It doesn't all of a sudden right here go this way. No, it has to have a flow. So from here, it had to come up through here, up through 0, and it repeats. And like I said, if you keep going, and it just keeps going, and it goes on forever. So that's what makes kind of sine and cosine. They're different because they're periodic. They repeat over a period of time. We're like an equation of a line, just kind of goes on forever in one direction. It doesn't change. If you look at a touchdown, it's just one shape there. It doesn't have kind of movement like these do. So that's what I usually did in pre-calc class. I think I kind of did it in both classes. So when you have y equals sine of x, sine started at 0. It kind of started in the middle. And then it went high, middle, low, middle, and then it just kept repeating. So the domain of this, you can put in any radian measure. Okay? If you're not going to first hour, come in for second hour. Go home. I yelled at a group fifth hour the other day. Her class was like, ooh, I yelled. We're going. So I moved over here for a second. I thought, oh, let me wait a couple seconds. Stepped over. I'm like, get to fifth hour or go home. Yeah, that's how it went. Sorry, Kylie, you have to list all this. Hey, they scattered though. They left. Okay. So on this one, the domain, I can put in any radian measure I want, and I will get a value that falls on here. My range is it fluctuates between 1 and negative 1. That's your high, low, and that's just what it's going to keep doing. So remember on this one, it isn't the connect the dots and get rigid, because if you will recall, all of these points like pi over 6, 1/2, pi over 4, all of those are represented, but that goes up to 30. I'm not even putting in there what at 15 degrees, whatever that one is, like the pi over 12s. I don't have those on there. So these are just some points on this unit circle. Remember, there's a lot of radian measures between 0 and 2 pi that if you go to like pi, okay, there's the 1/2. Okay, there's the one that goes to about 0.7. Oh, here's the one that goes to about 0.8. And then it kind of repeats. So even if you just did the dots that are on your snowman, they would just fall on here. But then there's lots of dots in between that we don't. But I kind of get it down to 5. So this was your sine graph. Okay. So then our next one was cosine. Okay. So with cosine, I'm doing the same thing. I'm taking the radian measure, but now I'm taking that first part of the coordinate because that represented cosine. So, and I don't need to make a big list here. Okay. 2 pi is the period. Usually I don't put in these quarter marks. You can if you, label them. Usually by the time it's all said and done, you know where it ends, you know where the halfway, and then you should know how the graph kind of goes there. Again, on here, y equals cosine. It's periodic graph, and after a period of time, it repeats. But with cosine, cosine starts up high. Okay, so we started up there. We start up high, middle, low, middle, and then back to. So it kind of looks, without graph paper, it looks decent. Okay, so it really is just a sine graph, but you just shifted it. So if you shift that sine graph over pi over 2 to the left, you end up with cosine. And remember, it just kind of keeps going, even into the negatives and then beyond 2 pi. So again, your domain can be anything. I can put any radian measure I want. I will end up with a point that's on this curve somewhere. Fluctuates between 1 and negative 1. Okay. So now, those were the two that I really focused on in pre-calc. How much did I focus on the other ones in the other? Did we do all of them? Like the reciprocal ones, like secant, cosecant, and I think I more introduced them, maybe. Okay, so let's look at a basic. And remember, this is just the basic look of the graph. I haven't even manipulated it with any numbers in there. Okay, so tan, same radian measures we're going to look at. But now I'm looking at these outside numbers. So I got 0, 0, and then I got square root 3 over 3. I got 1, square root 3, undefined. And then it kind of does the same thing. So tan looks different. These two graphs are pretty much the same. One's just a phase shift from the next one. So tan, now I'm going to go out to 2 pi, even though on tan, the period is pi. Because you'll start to repeat after that. So if you kind of go here to the first one was 0, 0, because like I said, I'm doing the coordinates of these. Okay. So I start here, and then by the time I hit pi over 2, okay, remember when it was undefined? That's where you talked about an asymptote. And then at 3 pi over 2, so on the half pies, it was undefined, because when you flipped over, 0 over 1, you couldn't, 1 over 0 doesn't exist. So then your graph kind of looks like this. And then the bottom one, and then at pi at 0. So it kind of looks like a bunch of discos, because right here, if you look at that, pi is where it repeats again. So that's where I hit 0, and then I kind of move up, and then I start down, and then you see another one. So this one actually has 2 periods in it, but just to see what it looks like. But it ends up being like a bunch of discos. So yeah, this came from down here, and there's another dotted line over here when you got into the negatives. Okay, but this one's a little different. Both of the ones at the top were 2 pi is where it, boom, repeated, and I did the whole graph again. On this one, if you're starting here at 0, it was at pi. Okay, now I started over again. So pi, tan's a little different, okay? Looks a little different, but like I said, just looks like a bunch of discos. It's kind of what it looks like there. All right, so those were, these were the main ones that we've always kind of dealt with in our class. This one, and I think maybe in regular pre-calc, what I did was I did that Desmos activity where you could just kind of explore, and I go type in tan, what's it do? And it looked something totally different than that. So I didn't really do much with it. Okay, so those were our 3 basic ones. Let's get into, how much do they get into? They get into cosecant. Okay, so cosecant. Cosecant is the reciprocal of sine, okay? So if I go back here, and remember sine was my second in my coordinates here. So I'm looking at those numbers now, but if they're reciprocal, I'm flipping them over. Okay, so it's basically these same values, but they were flipped over. Okay, so usually what I do when I start off doing cosecant, I just tell kids to graph sine. Just if it says cosecant, just ignore that and graph it as if it were sine. Okay, so I'm going to kind of do that here. So there's 1, there's -1. I'm going to go out to 2 pi. I'm going to go pi. I'm going to go pi over 2, and I'm going to go 3. pi over 2. So I'm going to kind of set it up the same way. Now, if you, let me see. I'll use purple paper. We'll try this one. Okay, so if you were to graph sine, here is, I'm just going to use this different pen here. This is what it would look like, correct? Okay, but this is why I tell you to do this, just because this makes it so much easier. Okay, so now remember, cosecant is the reciprocal of this. So basically, I'm turning all these values over. Well, what's that going to do when you have a 0? It's going to make it undefined. So right here at these dots where it's in the middle, okay, I'm going to put in my asymptotes there because that's what it's going to do. Okay, now, when you get over to here, and remember one of them was 1/2. Well, if I flip 1/2 over, that's going to give me 2. So what your graph is going to look like is this. Oh, I didn't even hit that point. Oops. We'll act like I did. Okay, so that's what it looks like. So when you graph cosecant, I just say treat it like sine. And then at your middle dots, put your asymptotes in, and then cosecant ends up being just a bunch of touchdown, pageant hands, touchdown, pageant hands, touchdown, pageant hands. It's still a periodic graph because at 2 pi, that's when I'll go back to touchdown. Okay, so that's why I just say if you guys got sine and cosine, you should have those pretty down pat. All right, so that's why I say just ignore it, graph it like it's sine. And then most kids, what they'll do, I mean, I know I have a pink line going through there, but they usually use kind of a light pencil, and then they just kind of go back and erase it. Or if you just leave it in light pencil, it's all good. It's not going to matter to me. But that's how I do, just graph sine, and then you can come back in here and do touchdown, pageant hands, touchdown, pageant hands. Okay, so with secant, I say do the same thing. Go back in here and graph as if, this looks so bad. 1, -1. So what I tell the kids, go back and graph it as if it were cos. So I kind of do. That way you don't have to remember too much. All you have to remember is, sine and cosine with these, and then you're good. Okay, so my asymptotes are going to be where? Okay, on the halves. So right when you get your graph done, it's those kind of middle points there. So I'm going to come in here and do that. And then from there, it's still touchdowns and pageant hands, except for this one just starts at. Oh, I was going to finish, but then hey. So it kind of looks like this, but remember, oh, that's really, really bad. But that would have been a touchdown. If it keeps going, you would have had a touchdown. That looks really bad. Oh, I can't fix it because it's in pen. Okay, you're just going to have to deal with my craptastic stuff. So it's still pageant hands and a bunch of touchdowns. And like I said, here at pi over 2, this pink line is going to go down like this, so that one would have went up. So, but it's still 2 pi where it kind of comes back up here to that 1. So you went 1 off to infinity, and then down below you were infinity up to 1, and then down, and then you came down and hit 1. So it's still, the period is 2 pi. Okay. So that's just looks really crappy. It looks like a sad, mean graph almost. Like a frowny face, almost eyes. Yeah, it's bad. Okay. Cotangent. Now this one is a little bit different. Okay, I'm gonna come out and I'm just gonna go to pi anyway, even though the period's gonna be pi. And we'll do this. Pi over 2, I got 3 pi over 2. Okay, so where were your asymptotes at on tan? They were on the halves, right? Okay, so when you flip that over, that's going to become a 0. So now where you had zeros before, that's where your asymptotes would be. So on this one, now your asymptotes are going to be on multiples of, marker for that one, kind of on the multiples of pi. Okay, so if you had asymptotes before, if you're doing a reciprocal, well, that's going to put those back to 0. And then the ones you had the 0 before, when you flip that over, that's going to do the undefined. So now this one, now remember, the other one was a disco, but this is going to kind of be the negative disco, because if your numbers were going up, well, your numbers are going to come down through. So before, when you had, okay, so before where you had your asymptotes, those are now your zeros. So you can mark your halves as zeros. And just remember, when you flip something over, it's going to flip it around there. Okay, that's what a reciprocal is going to do. So this is what cotangent looks like. Again, its period is pi. Because at pi, I get an asymptote, and then I start it up. This tan got split up because it started at that 0. But those are your 6 graphs. Sine and cosine you should have down pretty good, which therefore means you have these down pretty good, because you can treat them like sine and cosine and then go back and asymptote and then touchdown pageant hands. I would say it would be tan and cotangent that would be the ones that are a little different, not difficult, but a little different. And it changes because the period is pi. Pi is when it starts over again. So that periodic function is a little bit different. Okay, but these two should be good if you have the other two good. Okay, so the last thing I want to pull, come on, girl, do better. Okay, nope, pre-calc. Where's everything? How did I somehow screw this up? How did I somehow get a folder inside of a folder? So now I have 2 pre-calcs to open. What's wrong with me?
You put a folder instead of a folder name both the same thing.
Uh-huh.
So that's a start.
So how do I get rid of one and just call it one thing?
You go through and select all the folders or all the files in the one folder and move them up into the other.
Sounds like work.
Yeah.
I'll just leave it pre-calc. I'll just be that kid. Okay. So now, the graphs I showed you were just standard graphs of sine, cosine, tan, and their reciprocals. But we know from experience that I'm going to manipulate them a little bit. So here were the equations, and it doesn't matter on this if I'm using sine, cosecant, cotangent, whatever. All of these letters apply to, and I can post this in the, so you don't have to write anything down. I can post this whole thing. It's just graphing sine and cosine, but this applies to tan also. So here's your equation. So this is like the equation from the beginning where we were doing stuff with x squared and x cubed. But I said, well, when I get to trig, b will come into play, and then I'll get rid of the power. You won't have the little n there, but it can kind of go with anything. So yeah, plus or minus a. A is always there. It's always parked in front of sine, cosine, tan, others. If there's not a number there, there's always a 1. Okay. B is going to be, that number is going to be parked in front of those parentheses. If there's no parentheses, it'll be parked in front of the x. It'll be attached to that. If there's not a number there in front of the x, like ours, then that means 1. Okay. C will always be in the parentheses. Remember, this is the opposite of what you think. So if it said x plus 5, move it to the left 5. So that didn't change. And then D on the N is plus or minus, and that will, and D is the only one that can kind of move. Okay. It can be the very last number you see, like plus 7, or your equation could start off with 7 plus 2 sine. It can be the first number or the last number, but all the other ones are attached or where they should be, but D can kind of move around. Let me look in your book real quick to see what they use for. So I know in the old pre-calc book, they didn't use A, B, C, and D, and I thought it was stupid. And so that book does though. So I bet this book does. Okay. I don't know why they didn't use that. Okay, so remember A was your amplitude. And if you had a whole number there, it kind of stretched it out. If it was a fraction, something less than 1, then it kind of shrunk it down. Remember, if it's negative, that's going to flip the graph. So if you look at sine, it's still going to start at 0, but then it would move down instead of going up to 1. Okay. Period. How long it takes for one cycle of that graph before it starts to repeat. So if you have a whole number in there, it's going to shorten up your graph. You're going to see within the, let's say within 2 pi, you may see 2 or 3 graphs in that amount of time. If it's a fraction, it stretches it out. So if you look at, if it was maybe like a 1/2, okay, by the time you hit 2 pi, you should see half of a graph. I will say this, I need to kind of edit this because to find the period, you take 2 pi divided by b, but if it's tan, you would take pi divided by whatever that number's there. So I need to add that in there, but I don't spend a lot of time with tan in regular pre-calc. So I will add that in there for tan. C is a phase shift. That's just shifting it left or right. So if you do the phase shift on sine, you would end up with cosine. All right, so remember, it's kind of the opposite of what you think. D is a vertical translation. It just physically picks it up, moves it down, and it's exactly what you think. Okay, and I don't need that right there. Okay, so I will put this in your Google Classroom just to have. It's going to have other stuff in here, as in talks about cosine, there's cos, talks about sine, there's sine. It has that in there, and talks about radians, which we have, but it doesn't have any of the tan. So I'll have to kind of add that on the period there. But I'm going to stop there because that's a lot for Kylie to listen to. But I will post that in there. Okay, let's see if this worked. Stop recording.